पुलिस वाले इतना बंदोबस्त फोटो फोटो जान देगा लेंगे कि दे तो पुलिस वाला खड़े हुए हेलमेट लगा के आ गया ऑफिस पूरी उत्तर प्रदेश में पूरी पुलिस खड़ी है कोई नहीं पढ़ते लोग के सामने
बाबा इधर भैया सिंगम का कवर इधर फेंके भैया
Assalamu alaikum to everybody. In the previous class, we were discussing about the kinetic theory of gases. Then we have taken kinetic gas equation, kinetic energy of gas molecules, and lastly, we have taken the different type of velocities, and we have taken problems based on that. That is the end of the section. Now we are going to another section. This is supposed to be very important section. Usually Boyle's law, Charles' law, Avogadro's law, all those type of laws, they are not suitable for competitive examinations because all those laws you have already done in your lower classes. Therefore, the examiner of whether it is a NEET examiner or IIT examiner, they usually start the way of asking question from Dalton's law. Dalton's law of partial pressure is new to you. Graham's law of diffusion is new to you. Then kinetic theory of gases, kinetic gas equation, distribution of molecular velocities, all these new topics, they are supposed to be more important, right? I am not saying that the laws which we have studied should not be considered. They should be also studied. Relatively, we should give more importance as we are going to the end section of this chapter. Right now, when we are discussing today's topic, we have a discussion up to this time. We have already used the word ideal gases, ideal gases. We have done so many problems and then we have used the word ideal gases. Now the question comes here, okay, sir, what is the problem with respect to ideal gases? Whether do you have ideal gas available in nature or not? If not, then what is available? All these discussions will start today. And this is a very required, interesting topic with respect to examination point of view. Come on. First, my topic will be something like this. I'll create my own way of a style of creating topics. We take, first of all, sir, let us again go back and say, what do you mean by the word ideal gases first, right? Don't write the name of the section, that will write later on. Leave some space and don't write along with me. First understand, then I'll give you time to write down as usual. Ideal gases. What are ideal gases? Whatever we have done till now, what we say, sir, ideal gases are supposed to be those gases which obeys all the gas laws. PV is equal to nRT, Boyle's law, Charles' law, Avogadro's law, and they should obey PV is equal to nRT, Dalton's law of partial pressure, Graham's law of diffusion, right? All these laws are laws to be obeyed. Remember that obeying the laws is not ideality. Obeying the laws at all temperature and pressure is important. At all pressure, lower pressure, yes. Higher pressure, yes. Moderate pressure, yes. If it is possible, then only it is called an ideal gas. Very tough condition, we can say. right? Obeys all gas laws ideal gas equation. Kinetic gas equation. What is ideal gas equation? PV is equal to nRT, and kinetic gas equation what was that? PV is equal to 1 by 3 capital N V RMS square. Obeys all gas laws, ideal gas equation and kinetic gas equation. This is half journey, half part. Yet, this is important. All ranges of temperature and pressure. This is important. Whether you are talking about lower temperature, higher temperature, lower pressure, higher pressure, moderate temperature. At all conditions, if a gas obeys these laws, then yes, that is supposed to be an ideal gas. Okay, right. One more thing we have learned in kinetic theory of gases, intermolecular force of attractions must be equal to 0, right? One more thing we have learned, that a gas is said to be ideal gas if actual volume, are you able to recall? Yes, we have said actual volume of gas molecules is negligible as compared to total volume of gas. And what is total volume of gas? Volume of container. Total volume of gas. These are the requirements for a gas to be declared as an ideal gas, right? And these are possible questions also to us. Now, once you're having all these conditions, then the question comes here in this case, sir, do you have gases available in nature obeying all these conditions, right? Naturally, we have to discuss only with respect to those gases which are available in nature. For that purpose, our question is, do you have possibility of ideal gases in nature, right? Remember, when I have discussed the kinetic gas equation or theory of kinetic gases, then I said there are 2 points which we are going to prove that they are wrong under certain conditions and they are correct some other conditions. Today, we'll try to enjoy that one. If these 2 conditions are obeyed, the gas is said to be ideal gas. If these 2 statements are not valid, then you have to say, yes, sir, this is supposed to be non-ideal gas. It is supposed to be a real gas, right? Come on, for that purpose, what I should enjoy? Suppose, for example, I'm having a sample of gas. Consider a container. We have taken something like this. Cubical vessel. In this cubical vessel, I am having certain amount of gas enclosed, right? Now the question is, what do you mean by the word actual volume of gas molecules? What do you mean by the word total volume of gas? You know total volume of gas because you already is done. The total volume of gas is equal to volume of container. Okay. Now, suppose for example, this container is of 10 liters, suppose 10 liters, right? And now suppose for example, if I am saying, sir, I'm having gas molecules in this one, right? How many gas molecules? Say for example, I have selected some molecules like this. Suppose if they are available as if they were in the solid state, I am arranging gas molecules in the container as if they were in solid state, closely packed, right? Come on. 1 million gas molecules, 2 million gas molecules, 3 million gas molecules. Assume like that. Then 6 million gas molecules, 9 million gas molecules, three-dimensional, right? Now, what is this? This is known as actual volume of gas molecules. That means actual volume of gas molecule means that much volume of gases which are considered are occupied when they are supposed to be in the solid state, like this, right? They will never be in this way. We are assuming that suppose if they are available like this, how much volume they will occupy. This is known as actual volume of all gas molecules in the container. For example, if suppose you are having offline system and you are sitting in the classroom, volume of a boy, volume of another boy, volume of another boy. Like this, you collect volume of all the boys available in our class. Now we are having 97 students in the class. Volume of all 97 students is one factor. Volume of the whole class, let us say whole campus, right? If you consider that, that is known as what is volume of all the boys? Actual volume of gas molecules. And what is volume of the campus? That is volume of the gas, because it can be 10 liters, it can be 100 liters also, because I can change the container. I cannot change the volume of actual volume of gas molecules. It is not in my control, because every gas molecule will behave as a rigid sphere, as if you have played with marbles in your childhood, those glass marbles, as if we are having, can you press it? No, sir, I cannot press it. Exactly in a similar way, individual gas molecule will behave as a rigid sphere. Therefore, as a boy or a girl in the classroom occupies a specific space known as volume of the student, exactly there will be a volume of gas molecule, but this is called actual volume. Suppose this actual volume is 1 liter, right? Suppose, for example, the actual volume of gas molecule is taken as 1 liter. Now, if you are having this as 1 liter and then this is supposed to be 10 liters, then come on, this is normal situation. Now I'm applying conditions. What are conditions possible to us? Let us take condition like this. Condition number 1, high temperature and low pressure. Suppose, for example, if I'm applying this condition. Now, what is my job today? My job is to check at this condition, if these two statements are applicable, I should say gas is ideal gas. At this condition, if these two statements are not applicable, I have to say, sir, this gas is non-ideal gas. What is the name of non-ideal gas? Real gas. They are called as real gas. Now, suppose, for example, if I'm having high temperature, what happens here? As the temperature increases, go to Mr. Charles. What Charles law says? As you increase temperature, volume of gas increases. Which volume increases? This volume increases. Remember, you are not going to change the actual volume of gas molecules, right? You can increase the volume of room. You can decrease the volume of room. You cannot increase or decrease the volume of a student or a human being. A gas molecule will have rigid, specific nature. Therefore, it is fixed. So if you are saying as you increase temperature, high temperature, volume increases. No, sir. I'm having low pressure also. As the pressure decreases, volume increases. Mr. Boyle says these two statements. Now, what is the meaning of this? This means to say volume of gas is increasing. Suppose, for example, at this condition, volume of gas, come on, how much? Becomes 10 liters it was there. Now, suppose, for example, it is becoming as 1000 liters. Suppose, right? By application of volume, the high temperature and low pressure, I'm having this condition. And what about actual volume? Volume actual. What happened this one? Sir, this remains 1 liter. Now, there is a boy in our class who is saying I am having 1000 rupees, and neighboring boy is saying that I am having 1 rupee coin also in my pocket. What do you say? This is negligible. That means actual volume of gas molecule is negligible as compared to total volume of the gas. This is true under high temperature and low pressure. Okay, it means to say under this condition, gases will have ideal behavior. Okay, come on. If you are saying that volume of gas is 1000 liters as compared to 1 liter, what is happening? Molecules are going away from each other, or the molecules are coming close to each other. You will accept, sir, molecules are going away from each other. As the molecules are going away from each other, intermolecular force of attraction decreases, 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 and becomes negligible. Okay, under this condition, both of these assumptions made by kinetic theory of gases are found to be correct. Therefore, we say the gases will have ideal enjoyment. Therefore, what is our conclusion? The conclusion is, remember, as temperature increases and pressure decreases, as temperature increases and pressure decreases, take care of the language, gases what is that English language? A beautiful way of saying it. Sir, as you're increasing temperature, as you're decreasing the pressure, I am not writing gases becomes real, sorry, ideal. No, I'm not saying like this. What I'm saying, gases tends to become ideal, tends to become ideal, right? Remember that in your life also. What is your target? Sir, I want to try to become a very disciplined type of student. I want to become a disciplined type of human being. I want to become a top ranker. I am trying to become a top ranker. I am a top ranker. Statement is false. I am trying to become a top ranker. So in a similar way, what is ideal gas? No, no, no. What is the condition suitable for ideality? Condition is high temperature, low pressure. Now in the question, he has given 4 options. You have to do select that option where we have highest possible temperature, lowest possible pressure, and you say this is the condition where you can say the gas may become, may, again I am saying may become. I never say gases are ideal. It is applicable to our life. I am not an ideal human being. I am not an ideal teacher. What is that? Sir, I am trying to become an ideal teacher. I am trying to become an ideal student. Exactly in a similar way, if suppose, for example, your goes on increasing temperature, and if your goes on decreasing the pressure, gases tends to become ideal. Is it clear? Yes. Now, suppose, for example, you are saying, sir, if you reverse the suppose, for example, if you're having low temperature and high pressure, if we are having this one, right, I'll increase the value to further enjoy the meaning of the discussion. 100 liters was there, and this 1 liter. Now it becomes as, once you are applying the condition of high temperature and low pressure, this is becoming how much? 10,000 liters. Now you can appreciate, yes, sir, as compared to this value, I should neglect it. I should neglect it. That means these 2 assumptions are perfectly correct under this. Now, suppose, for example, I am applying low temperature, high pressure, other possible condition. What happens? Very simple, sir. Suppose, for example, you are saying as temperature decreases, what happens? Charles was say volume decreases. No, no, sir. As you increase the pressure, what happens? Volume decreases. Which volume decreases? Actual volume of gas molecules are never affected. Therefore, volume of gas decreases. What was volume of gas? 100 liters. Suppose it becomes 10 liters. Now, and then what is actual volume of gas molecules? Sir, actual volume of gas molecules never be affected. How much? 1 liter. Now, if your neighbor is saying, I am having 10 rupees, and you are saying, I am having 1 rupee coin, no one can say it is negligible. Are you able to understand? This is countable. Hence, actual volume of gas molecule is negligible as compared to total volume of the gas is a wrong sentence. This assumption is not applicable. And if suppose volume of gas is 10 liters as compared to 100 liters, molecules are coming close together. As the molecules come close together, intermolecular force of attraction increases. You cannot say they are zero. As students come close together, friendship increases day by day. Exactly in a similar way, both of these assumptions are found to be wrong. They are found to be not applicable under this condition. NEET boys, doctors, these type of all theoretical questions are very much possible for you. This implies what I have to say. Now take care of the sentence and enjoy the beauty of language. As temperature decreases and pressure increases, gases, take care of the language, becomes real. I am not using the language tends to become real. You want to become a murderer, give only one murder, finished. No, sir, after doing 20 murders, people should call as murderer. No, not like that. बुराई के लिए एक चीज काफी है, अच्छाई के लिए there is no limit. Sir, मैं अच्छा बनना चाहता हूँ, चलिए बनते जाइए. But for reality, yes, apply condition, it becomes real. Here the word becomes real. Not, I'm not saying tending to become real. Okay. Therefore, as you're increasing temperature and as you're decreasing the pressure, gases tends towards ideality. Whereas if you decrease the pressure and decrease the temperature and increase the pressure, gases becomes real. ठीक है, एक पॉइंट समझ में आ गया. अब turn the photograph. Sir, what is available in our nature? हमारे पास क्या है? What is available in our nature? In our nature, we are having low temperature, 25 degrees centigrade. Normally, we take room temperature. Now, it is different story that because of our luxurious life, we are using chlorofluoro compounds in case of refrigeration system, and we are increasing the temperature of atmosphere, and we are trying to decrease the ozone thickness of ozone layer. That is different issue. God has created low temperature, and God has created very high pressure. Sir, how you are saying high pressure? It's only one atmosphere. Why you are talking in terms of one atmosphere? Talk in terms of millimeter of Hg, 760 millimeter of Hg. Why I am saying so? Because go back to 10th class, cathode rays experiment. What we have done? Sir, 10 power minus 3 millimeter of Hg. That much low pressure you can create, but God has given you 760 millimeter of Hg in the atmosphere. Therefore, remember, natural conditions are, universal conditions are low temperature and high pressure. Therefore, in nature, ideal gases do not exist. Yes, in nature, ideal gases do not exist. We have to create ideality. We have to create ideality. Someone is saying that I am very good. No, you have to try to become good. That means if you are applying conditions, then a gas may become ideal, but nature has given you all real gases. Therefore, in nature, we do not have ideal gases. We are having real gases. Okay, sir, I got the point. Once I got the point that we are having real gases, then why to talk about PV is equal to nRT? Why to talk about PV is equal to 1 by 3 capital M V Rm squared? Let us have a new equation that is known as equation for real gases. Our next topic is to understand what is the equation of a real gas. Write down this first, then we'll proceed. Write down heading as, okay, I have not given you the name of heading. Today's our topic is, yes, very good, very good. Non-ideal behavior. Non-ideal nature of gases. Right? Go ahead. Conditions available in nature are low temperature and high pressure. Therefore, ideal gases do not, underline, exist in nature. Next point, continue that one. All the gases in nature are non-ideal or real gases. A real gas may be converted by increasing temperature, increase in temperature and decrease in pressure. Tell them that. Abrar, are you not listening me properly? We have never discussed the word velocity today. Volume of gas molecules, volume, actual volume of gas molecules, total volume of the gas. Velocity का word कहीं नहीं आया यहाँ पे बेटा. थोड़ा सा ध्यान से पढ़ा करो. If you are listening, then why you are asking beta? When you are listening, where is the question of velocity here? वेलोसिटी का वर्ड ही नहीं आया ना बेटा पूरी क्लास में. आप सुन रहे बोल रहे हैं और पूछ रहे हैं कि वेलोसिटी है या वॉल्यूम है. मतलब आप ये पूरा तुम कंप्लीट जीरो हो गया आपके लिए. क्या समझाया हमने? पूरा गेम वॉल्यूम के ऊपर चल रहा था. आप बोल रहे हैं आप सर राम को सीता क्या होना है. चलिए please try to become ideal student. Try to become ideal. And make a star on these 2 points. So these 2 points, we are playing game with only these 2 points. कभी ये statements सही होंगे, कभी ये statements गलत होंगे. If these 2 statements are right, gas is ideal. If the statements are not applicable, the gas is said to be real gas. Got it? Here we have conceptual questions, both doctors and scientists. We have conceptual questions. These type of discussions may not be available in textbooks. Therefore, write down properly. Try to revise properly at home when you are having your study hours, try to make it happen. Any question to ask? Any doubt? Okay, nice. Come on. We have started, right? Idiots are coming into the class. Their time is started. आपकी क्लास में एक दो है शायद, बहुत हरामी किस्म के हैं, आते हैं लात मारे तो चले जाते हैं, चले गए आप, फिर आप उसको पासवर्ड देते होंगे, फिर आ जाता हूँ। इज इट ओवर? मुसलमान शर्म आना चाहिए, माँ बाप कौन से है समझ में। चले प्रोसीड, इज इट ओवर? नॉन मुस्लिम्स के पान अच्छा ऐसे गधों को पढ़ने के लिए। Go ahead, go ahead, go ahead, go ahead. No problem. Right now, right now, right now. Allah. Right. Now, if suppose, for example, you reached up to this point, you have a clear idea that actually we should talk about ideal behavior. Yes, but there is a problem. The problem is not from our side. The problem is nature has created certain conditions. At those conditions, the assumptions and the applicability is not suitable. Therefore, we say, sir, at these conditions, we don't have ideal gases. Therefore, when we talk about real gases, then the question comes, what about real behavior? Is it over? Right, come on. Afnan, what is the problem, beta? Temperature से पहले last line में पूछना है आप. In last line, what is before T? ठीक है, आगे बढ़ो आप, जरा आगे बढ़ो. Before P क्या है देखो. Right. Now our question comes here in this case, that what about the real behavior, right? We don't have time today. Sorry, I have some work stuck up, therefore I joined late. Tomorrow we'll continue. To consider that one, we have 5 equations available, real gases. To consider, we have 5 equations, but in our syllabus, we have only 1 equation. Write down heading, that we'll discuss in the next class. Write down Van der Waals equation. Take care of spelling and the way of writing small v, Van der Waals. Not your house wall, it is walls like this. Equation for real gases, but people say equation of state. Why it is called equation of state, and what is this equation? This is all game of 4 marks that we'll discuss in the next class. Write down the heading, एंड सोहेल अहमद, फिर से आप वही कर रहे हैं, आपको लिखना कुछ नहीं है बेटा, आपको कुछ भी नहीं मालूम है, यू आर जीरो इन गैसेस स्टेट, जस्ट लिसन, राइट? नोबल गैसेस कौन सी चीज है आपको नहीं मालूम, वैन वाल इक्वेशन कौन सी चीज है आपको नहीं मालूम, इस वास्ते खामोश मुंह बंद करके सिर्फ सुनिए, पढ़ लीजिए, चले जाइए। उतना समझ गए तो आप समझिए यू बिकम आइडियल स्टूडेंट। बकवास करना मत कीजिए। शैल आई गो, लीव इट? अस्सलाम वालेकुम। गधे हैं।